Okay, check your watches, check your calendars. It is Thursday, February 19th, 2026. And I know usually a Thursday in mid-February just means you're trying to coast into the weekend, you're thinking about groceries, maybe catching a movie, just trying to keep warm until spring hits.
But while we're down here worrying about the thermostat and the weekend grocery run, well, the solar system has other plans.
Exactly. The solar system is currently prepping for something massive in just over a week. We are talking about a major cosmic get-together peaking on February 28th. The headlines and my social media feed are calling it a planetary parade.
Right.
Now, when I hear parade, I think of floats and marching bands and ticker tape, but in astronomical terms, this is a pretty big deal, right?
It is a significant deal. We aren't talking about just two planets passing in the night or a nice conjunction of the Moon and Venus.
Which happens fairly often.
Yeah, that's pretty common.
Yeah.
We are talking about 6 planets visible in the sky at the same time.
6 planets. That is a crowded sky. So, for today's deep dive, we have pulled together a massive stack of sources to make sure you are ready.
We have.
We've got guides from NASA, specific observing tips from the Astronomical League, analysis from Earth Sky, and some really detailed breakdowns from Starwalk and Ray's astrophotography.
It's a comprehensive collection. And what's really useful about these sources is that they cover the whole spectrum from the naked eye experience where you just look up
Right.
to the dust off your telescope level where you're hunting for the faint stuff.
And our mission today is simple. We want to take you, the learner from casual observer, to informed stargazer by the time the sun goes down on the 28th. We want you to be able to step outside, look up, and actually understand the mechanics of what you're seeing without feeling overwhelmed, because looking at a bunch of dots is one thing.
But knowing the neighborhood is another. And it's easier said than done because timing is absolutely everything with this event. If you go out at the wrong time or look in the wrong direction, you'll see absolutely nothing but stars.
So let's unpack this. February 28, 2026, the main event. First things first, who is on the guest list?
Right. So the lineup for the evening of the 28th includes Jupiter, Uranus, Saturn, Neptune, Venus, and Mercury.
Okay, I'm counting. That's 6. But I feel like we're missing a big name, the red planet. Where is Mars? Usually, Mars loves to crash these parties.
That is the most common question we're seeing in the forums. Mars is the notable absentee.
Really?
Yeah, if you look at the charts from Ray's astrophotography, Mars is technically around, but it's effectively a no-show for this specific party.
Why is that? Did it get lost?
It's all about orbital position. Depending on exactly when you look in late February, Mars is either lost in the sun's glare or it's strictly a morning object.
Oh,
It's on the other side of the clock, essentially. So for this evening parade, Mars is sitting it out.
okay. So Mars declined the invite. But we still have 6 heavy hitters. Now let's talk about the visual. When we say parade, I think people imagine a straight line, like beads on a string stretching up from the horizon, perfectly vertical.
And that is the classic misconception. If you go out expecting a ruler straight line shooting up from the ground, you might be confused.
It's not like that.
No, it's an arc. Think of it as a graceful, giant curve stretching across the sky.
And that curve isn't random, is it? This touches on one of those key concepts we wanted to clarify.
Exactly. That curve is the ecliptic.
Define that for us, because I hear that word thrown around a lot in astrology and astronomy, but what is it physically?
The ecliptic is essentially the path the sun travels across our sky during the day. But more importantly, it represents the plane of our solar system.
Okay.
Imagine the solar system is a flat disk, like a vinyl record or a pancake. The planets, Earth included, all orbit roughly on that flat disk.
So when we look up and see them lined up, we aren't seeing them stack on top of each other. We're seeing the edge of that disk.
Precisely. You are seeing the architecture of the neighborhood. Since we are all stuck to this flat plane, the planets will always appear to follow that same track across the sky.
The same track the sun and moon follow.
The very same. It's a glimpse into the 3D structure of space, viewed from our vantage point.
That is so cool. It's like seeing the structural beams of the solar system. Now, looking at Ray's astrophotography data, I saw a statistic that really highlighted how rare this specific grouping is. They have a ranking system.
They do. They performed a statistical analysis of planetary groupings over the last 50 years, ranking them based on how tightly grouped the planets are.
Meaning how small of a slice of the sky they occupy.
Exactly. And this event on February 28th ranks as a rank 2 event in the last half century.
Rank 2 out of 50 years. So this isn't a happens every Tuesday situation.
No, not at all. Getting 6 planets into a sector this small is statistically significant. It's a density of planets we don't often get. I mean, it's a crowded house.
Okay, so the planets are there, they are rare, but, and here's the reality check for everyone listening, just because they are there doesn't mean you can see them all with just your eyeballs, right?
Right.
I don't want people going out expecting a laser light show and seeing darkness.
And that's right. This is where we need to manage expectations so people don't go out and get disappointed. We have to split this into 2 groups, the naked eye squad and the optical aid squad.
Break it down. Who can I see if I just walk out onto my porch with a cup of coffee?
Visible to the naked eye, assuming you have clear skies and decent vision, you have Jupiter, Saturn, Venus, and Mercury.
4 out of 6. That's still pretty good.
It is. But for Uranus and Neptune, you are going to need help. Optical aid is mandatory.
Binoculars.
Binoculars at a minimum, but a small telescope is even better. They are ice giants. They're incredibly far away.
Yeah.
And they are just too faint for the human eye to pick up.
Okay. But even if I don't have binoculars, seeing 4 planets at once is impressive. Now, the sky is huge. If I step outside, where do I even start? Is there a landmark?
Yes. The easiest anchor point is the moon. On the 28th, the moon is going to be in a waxing gibbous phase.
Which means it's mostly full, right?
About 90% illuminated. It'll be big and bright. And on this specific night, it's going to be sitting very, very close to Jupiter.
Perfect. So find the bright moon, look for the incredibly bright star-looking thing next to it. Boom, that's Jupiter.
You're on the board.
Yeah.
Exactly. That is your anchor at the top of the line. Start there, and you know you're looking in the right general direction.
Okay, so we know who is there. We know where to start. Now let's talk logistics, because you mentioned earlier that timing is the make or break factor here.
It really is.
If I go out at midnight to see this, am I going to be successful?
No.
Yeah.
You will see absolutely nothing. If you wait until midnight, the party is over. The window is actually surprisingly short.
How short?
You want to be looking about 1 hour after sunset.
1 hour? That's a tight turnaround. Well, why the rush? Why can't we see them all night?
It's because of the leaders of the parade, Mercury and Venus. They are what we call inner planets. They orbit between Earth and the Sun.
Right. They're on the inside track.
Because of that orbit, from our perspective on Earth, they never stray too far from the sun in the sky.
They're tethered to it visually.
That's a great way to put it. So when the sun sets, Venus and Mercury follow it down towards the horizon pretty quickly.
So it's a race against the rotation of the Earth?
It is, yeah. They are low on the western horizon. If you wait 2 or 3 hours after sunset, they will have set, and you've missed the parade aspect. You'll just be looking at Jupiter and Saturn.
Okay, so let's walk the listener through this step by step. It's February 28th. Sun has just set. We've waited about 45 minutes to an hour. It's getting dark. We are facing west.
Facing west, we're going to do a west to east hop. This is the best way to navigate it visually.
Okay, I'm facing west. What is the first thing I see?
Low in the west, you cannot miss Venus. It is dazzlingly bright. Magnitude METIS 3.9.
And just as a refresher on magnitude, the lower the number, the brighter the object.
Correct. The scale is backward. Negative numbers are incredibly bright. Venus is the 3rd brightest object in the sky after the sun and moon. It'll be the lighthouse on the horizon.
That's so you can't mistake it.
You honestly can't mistake it for anything else.
Okay, Venus is the lighthouse. Got it. Now, you said Mercury is the tricky one.
Mercury is the challenge level. It's near Venus, also in the constellation Pisces, but it's much fainter and physically lower in the sky.
So you have to be quick.
You have to catch it before it dips below the tree line.
And this brings us to a really timely tip from our sources regarding Mercury. This is actually why we wanted to get this episode out today, February 19th.
Yes. This is the homework assignment.
Right, because if you want to find Mercury on the 28th, the experts say you should actually start looking tonight.
Exactly. Today, Thursday, February 19th, Mercury is at what astronomers call greatest eastern elongation.
That sounds technical. Decode that for us.
It just means that from our viewpoint on Earth, Mercury is at its maximum distance from the sun.
Oh.
It's as high in the evening sky as it's going to get during this cycle. It is literally the best night to spot it.
So the logic is, go out tonight, find Venus, and look for that little speck nearby. If you can spot it tonight while it's easy.
Then you'll know exactly where to look on the 28th when the crowd gets bigger.
That's smart.
Precisely.
Yeah.
Train your eye tonight. It takes a little practice to pick it out of the twilight.
That is great advice. Practice run tonight.
Woo!
Okay, back to the 28th. We have Venus and Mercury low in the west. We are moving up the arc. Who is next?
Higher up in the constellation Pisces, you'll find Saturn.
And Saturn looks different than the stars, doesn't it?
It does. It has a steady, creamy yellowish glow. And this is a key tip for beginners. Stars twinkle. Planets generally don't.
Why is that? I've always heard that rule, but what's the physics there?
Stars are point sources of light. They are so far away, they're infinitely small points. And that light is coming through our turbulent atmosphere.
All the heat waves and air currents.
Right, so the light gets bounced around. That's the twinkle. Planets are much closer, so they appear as tiny disks. That little bit of width makes the light much more stable.
So if it's twinkling, it's probably a star. If it's a steady glow, it's a planet.
90% of the time, that rule works. Now, right next to Saturn, and I mean right next to it, is Neptune.
How close are we talking?
Less than 1 degree away.
That's tiny.
It's very close.
Yeah.
But again, Neptune is invisible to the naked eye. This is where you grab those binoculars.
Okay.
If you scan Saturn, you might see a faint bluish star right next to it. That is actually the planet Neptune.
So we've got the Venus-Mercury pair low down, the Saturn-Neptune pair higher up. Who's next in the conga line?
Keep moving east into the constellation Taurus. If you're looking for Uranus, it's hanging out near the famous Pleiades star cluster, the Seven Sisters.
I love the Pleiades. They look like a tiny little dipper.
They are distinctive. Uranus is about 5 degrees away from them. Again, binoculars are your friend here. It will look like a greenish-blue dot.
But not a disk.
You likely won't see a disk unless you have a telescope. No.
And then finally, high in the east.
The king, Jupiter, in the constellation Gemini. As we said, it's the second brightest object in the night sky after Venus.
And it's got a guidepost.
And the moon will be right there, acting as a giant neon sign pointing at it.
So the line is Venus-Mercury at the bottom, scan up to Saturn-Neptune, keep going to Uranus near the Pleiades, and finish with Jupiter and the moon at the top.
That's your parade route.
I love that. Now, let's talk gear for a second. The Astronomical League had some specific recommendations on tools. They called binoculars the little instrument that can.
They did.
I feel like people always think they need a telescope, but binoculars are actually better for this.
For wide groupings like this, binoculars are often superior. A telescope zooms in too much, you lose the context.
Ah, okay.
Binoculars give you a wide field of view so you can see the relationship between the objects. The Astronomical League specifically recommends 7 by 35 or 10 by 50 sizes.
What do those numbers actually mean? I always get them mixed up.
The first number is magnification, so 7 times or 10 times closer. The second number is the aperture, the width of the front lenses in millimeters.
So why 10 by 50?
50-millimeter lenses let in a lot of light. That is crucial for spotting faint objects like Neptune. And 10x magnification is strong enough to see detail, but not so strong that the image shakes uncontrollably in your hands.
Right. It's the sweet spot for handheld astronomy.
Exactly.
That makes sense. Now, they also had a really cool tip for measuring distances without any tools at all. The ABCs of stargazing.
Yes.
Because you mentioned Uranus is 5 degrees away. How do I measure 5 degrees? Do I need a protractor?
No protractor needed.
Okay.
You use your body. It's a classic astronomer trick. If you hold your arm out fully extended,
Yeah.
go ahead and do it now. Make a
Right.
fist.
Okay.
That fist covers about 10 degrees of sky.
Fist is 10 degrees.
And just the tip of your index finger, that's about 1 degree.
Oh, wow.
So when we say Neptune is 1 degree from Saturn, that's a finger width. When we say Uranus is 5 degrees from the Pleiades, that's half a fist.
That is incredibly helpful. No ruler required, just your hand. Oh, and one more tool tip that I always forget, the flashlight.
The red flashlight. Critical.
Why specifically red? I've seen people using them, but I always assumed it was just to look cool.
It's biology. White light from your phone screen or a standard LED kills your night vision instantly. Instantly. A protein in your eye called rhodopsin breaks down in bright light. It takes your eyes 20 to 30 minutes to fully adapt to the dark again.
So checking your text messages basically resets the clock on your vision?
Instant reset. You lose all that sensitivity you built up. But red light has a longer wavelength and doesn't trigger that breakdown. You can read a map with red light and keep your night vision intact.
So put some red tape over your flashlight or buy a cheap astronomy light. Okay, let's pivot to the science for a second.
Sure.
We're calling this a parade, but sometimes you hear alignment. Is there a difference, or is that just semantics?
There is a difference, and
Oh.
it's an important distinction if you want to be precise. Planet Parade is a colloquial term.
It's the fun name.
It's the fun name. It just means a visual event where they are all in the sky. Planetary alignment is the strict astronomical term.
And this is where the perspective trick comes in, right? Because they aren't actually lining up in space.
Right. They aren't arranged like beads on a string stretching out from the sun. That almost never happens. The planets are at vastly different depths.
Billions of miles apart.
Exactly. Mercury is close. Neptune is billions of miles away.
So why do they look lined up?
It's because they are all currently within a certain sector of their orbits. Think of a pie chart. If you view the solar system from above, all these planets are currently within one quadrant, a 90-degree slice of the pie.
Okay. So they are gathered on one side of the house.
Exactly. And because we are also in that solar system looking out, that 90-degree spread compresses into our field of view. It's purely a line-of-sight effect.
Which brings us to the inevitable question. Every time the planets align, someone on the internet starts talking about gravity, earthquakes, tsunamis.
The end of the world. Ah, yes. The gravitational disaster myth. It arrives like clockwork.
Do we need to be worried? Is the combined gravity going to rip California off the map?
Not even a little bit. Starwalk actually had a great section debunking this. They confirmed, again, that planetary alignments do not cause earthquakes or tsunamis.
But gravity is real. They are pulling on us.
They are, but you have to understand the scale. Gravity weakens with distance, the inverse square law.
Right.
The moon is small, but it's close, so it pulls our tides. Jupiter is massive, but it is so far away that its gravitational pull on Earth is negligible.
Wow.
It's nothing compared to the influence of the moon and the sun. A jumbo jet flying over your house exerts more gravitational pull on you than Neptune does.
That's a great comparison. So we're safe.
You are safe.
Good to know. I won't cancel my subscription services. You mentioned technology earlier, specifically regarding perspective. I saw something about a planetary walk feature.
Yes, the Starwalk app. It's a great use of augmented reality. It essentially helps you visualize that invisible line we talked about.
So you hold your phone up.
You hold your phone up, and it overlays the position of the planets, helping you see the ones that might be too faint, like Uranus. It helps connect the dots.
It's amazing how tech has changed stargazing. It used to be just paper maps and a red light.
It lowers the barrier to entry, which is fantastic, and makes the sky accessible to everyone.
Okay, so February 28th is the big night. But let's say it's cloudy, or let's say our listener gets the bug and wants more. 2026 is actually a pretty packed year for the sky, isn't it?
It is a highlight reel year, and you don't have to wait long for the next event. Just a few days after the parade, on March 3rd, we have a total lunar eclipse.
Oh, the blood moon?
The blood moon. This happens when the moon passes into the Earth's shadow, the umbra. The Earth blocks the sunlight, but a little bit of light filters through our atmosphere.
Like a sunset projection.
Exactly. The Earth's atmosphere bends the red light onto the moon, turning it this deep, coppery red. It's eerie and beautiful.
Can everyone see it?
Well, here is the nuance. It's visible in North America, but it's an early morning event. And for a lot of North America, the moon might actually set while it's eclipsed.
Oh, really?
So you're catching the tail end of it. Asia and Australia get the prime time evening show for this one.
Okay, so check your local times for March 3rd. What's next on the calendar?
May 31st. We have a blue moon.
Now, does it actually look blue? Because I feel like that's another common myth.
Sadly, no. That's a common misconception. A blue moon just means it's the second full moon in a single calendar month.
So it's a calendar thing.
It's a quirk of the calendar, not a change in atmospheric color. But hey, it's still a full moon, and full moons are always lovely.
True. Okay, scrolling down, I see a big one on the list for August.
The big one. August 12th. Total solar eclipse.
The king of all astronomical events. Where is the path of totality?
This one is going to be spectacular for Europe. The path of totality hits Greenland, Iceland, and cuts right across Spain.
Spain is going to be busy that week.
Very busy. It will be the travel event of the summer. But if you are in the northeastern U.S., you aren't left out entirely.
We get a partial one?
You will see a partial eclipse, up to about 15% coverage depending on how far north you are. It's not totality day won't turn to night, but seeing a bite taken out of the sun is still a unique experience.
And the safety warning. We can't talk eclipses without the safety warning.
Mandatory warning. Never look at the sun directly, especially during a partial eclipse. You need ISO-certified solar eclipse glasses.
Not sunglasses.
Not sunglasses. You will damage your retinas permanently.
Got it. And August has a double header, right?
It does. Right around the same time, August 11th through the 13th, we have the Perseid meteor shower.
The Perseids are usually the reliable ones.
They are the best meteor shower of the year. They're bright, they leave trails, they are plentiful. And here's the good news. In 2026, the peak coincides with a new moon.
Which means dark skies.
Pitch black skies. Usually the moon washes out the fainter meteors. This year, there is no moonlight interference.
So a good year for them.
If you can get to a dark location away from city lights, 2026 is going to be a legendary year for the Perseids. You can see 60 to 100 meteors per hour.
That is something to look forward to. Summer camping trip, marked.
Absolutely.
Okay, let's bring it back to the present. We've covered a lot: the parade, the tools, the physics, the future events. If we want to synthesize this for the learner listening right now, what is the immediate game plan?
Immediate game plan. You have homework for tonight, February 19th.
Yeah.
Go outside about 45 minutes to an hour after sunset. Look west. Find Venus, the bright one. Then train your eyes to find that faint dot nearby. That's Mercury.
Catch it while it's high at elongation.
Exactly. Once you've done that, mark your calendar for February 28th. That's the supergroup performance. Jupiter, Uranus, Saturn, Neptune, Venus, Mercury.
And remember the arc. Venus low, Jupiter high.
And don't forget the moon near Jupiter as your guide.
You know, what I love about these deep dives is that we always find these little nuggets of perspective. And there was one thought from the research that really stuck with me about what we are actually seeing when we look at that arc.
The plane of the solar system.
Yeah. Can you expand on that one last time? Because I think that changes how you look at the sky.
It really does. When you go out on the 28th and you see that curved line of planets, don't just see bright dots.
Right.
Try to visualize that you are standing on a giant disk. You are seeing the edge of the disk that we all live on.
The disk of the solar system.
Right. You are seeing the architecture of our celestial neighborhood with your own eyes. You aren't just looking up, you're looking across our home system.
Wow.
It gives you a sense of scale and structure that you usually only get from textbook diagrams. But there it is, right over your roof, hanging in the dark.
That is a provocative thought to leave us with. We are living on a giant frisbee in space, and next week, we get to see the other passengers.
Couldn't have said it better myself.
Awesome. Well, thank you for guiding us through the galaxy today.
Always a pleasure.
And to everyone listening, good luck with the homework tonight. Let's hope for clear skies. Keep looking up.
All right, if you're a fan of looking up at the night sky, you are going to want to listen to this. There is a truly spectacular show coming up, and we're going to break down everything you need to know to see it for yourself. Go ahead and circle this date on your calendar, February 28th, 2026, because on this particular evening, the cosmos is putting on a show, a really rare one. It does take a little bit of planning, but the payoff is a view that, seriously, most people will never get to see in their entire lifetime. That's right, 6 planets. I mean, we are talking about Mercury, Venus, Jupiter, Saturn, Uranus, and Neptune. The whole gang, basically, all showing up in a single evening. But, you know, knowing it's happening is one thing. Actually getting out there and finding these worlds, that's another. So let's get into it. How can you actually witness this thing? Okay, so first things first, let's get some perspective here. Let's talk about why astronomers and skywatchers are, well, kind of freaking out about this particular event. It's not just any alignment. It's the rarity that makes it so special. Just think about it for a second. Our galaxy is this huge, sprawling place. We're talking over 200 billion stars. But for just one night, all that noise kind of fades into the background, and the spotlight is right here in our own cosmic backyard on 6 of our planetary neighbors. See, getting the planets to cluster like this from our point of view is, well, it's really, really hard. They're all zipping around in their own orbits at totally different speeds. So to put it in perspective, this specific alignment, it's the second rarest event of its kind in the last half-century. That's a big deal. So we're throwing around these terms like parade and alignment, but what do they actually mean? Let's clear the air and, bust a few myths while we're at it. Okay, so the official term, planetary alignment, sounds complicated, but it's really not. Now, you got to get this picture out of your head of them all forming a perfect straight line in space. That's not what happens. It just means that from where we're standing, right here on Earth, they all appear grouped together in the same little patch of sky. So, yeah, you're going to hear both of these terms, and honestly, they pretty much mean the same thing. Alignment is what these astronomers call it. Planet Parade is just, well, it's what the rest of us call it because it sounds cooler, and it perfectly describes what you're seeing, a parade of planets. And look, we have to talk about this, so let's just get it out of the way. You might see some crazy stuff online about earthquakes or tsunamis. Ignore it. It's all nonsense. Their combined gravity is so incredibly tiny from this distance, it has absolutely zero effect on Earth. The key takeaway here is this is a super cool thing to look at, not something to worry about. Okay, science class is over. Let's get to the good stuff. Your practical guide. This is the how-to part. This is how you're actually going to see this thing. Really, it all comes down to 3 key things. First, timing. You gotta start looking about an hour after your local sunset. Second, location. You need a clear view to the west. Get away from trees, get away from buildings. Any obstruction is gonna be your enemy. And third, you need to know where to look. The planets follow this invisible highway in the sky called the ecliptic. That's your treasure map. All right, so here's the lineup. Here's your cast of characters. Venus is going to be impossible to miss. It'll be the brightest thing up there, besides the moon. Like crazy bright. Jupiter will be right behind it, also super bright. Saturn and Mercury will be there too. But for the last 2, Uranus and Neptune, yeah, you're gonna need a little boost for those guys. Which, hey, is a perfect transition to our next topic, gear. What kind of equipment will you need to bring along for the show? And the answer might surprise you. You probably need a lot less than you think. Are you ready for this? 4 of the 6 planets, 4, are visible with just your eyes. No telescope, no binoculars, nothing. And get this, the moon is joining the party too. It'll be about 90% full, hanging out right near Jupiter, which is just gonna look awesome. Okay, so to catch all 6 and complete the set, you'll want to grab a simple pair of binoculars. They're really the secret weapon here. They'll pull in just enough light to reveal the faint little glows of Uranus and Neptune. Now, if you do have a telescope, or maybe you can borrow one, this is the perfect time to bust it out. But listen, I want to be clear. A telescope is absolutely not a requirement. You don't need one to enjoy this. All right, listen up, because this next part is super, super important. Let's manage some expectations so you're not disappointed, because that's the key to really enjoying this. This is probably the #1 rule of amateur astronomy, right here. Those jaw-dropping, super colorful photos you see from NASA, they're amazing. But they're made with long exposure cameras and tons of computer processing. What you're going to see is more subtle, but I'd argue it's way more profound because it's real. This is a perfect example of what I'm talking about. On the left, you've got the glossy, processed photograph. On the right, that's a much more honest look at what your eye actually picks up. The planets are going to look like bright, steady little dots of light. You won't see the rings of Saturn with just your eyes, but you will be seeing the light from Saturn, and that's incredible. Oh, and one more thing, you have to be fast. This is not an all-night event, not even close. Mercury and Venus are basically tethered to the sun, so once the sun sets, they're going to follow it down below the horizon pretty darn quick. You've got maybe less than an hour to see the whole lineup together. But hey, don't let that short time frame scare you off. Think of it more like an invitation. It's the perfect excuse to just get outside, look up, and maybe, just maybe, kick off a whole new hobby. Because at the end of the day, that's really what this is all about. It's about taking a moment to actually connect with the universe, to see our solar system in motion. And your reward for making that little bit of effort? It's a personal view of the cosmos, something that's all yours. So make a plan, and I hope you have clear skies.